Hi everyone, I am Soininen. I'm a PhD student at the University of Helsinki and I focus on reinforcing microbiological diversity and human health in urban areas. I talk about green walls as enhancers of skin bacterial communities and immunomodulation. Green walls are basically vegetation-covered walls that can be installed indoors, for example to improve indoor air quality and to make the space more comfortable. The green walls in this study circulate indoor air through the green wall, through its soilless plant substrate and plant roots inhabited by plant-borne microbes. We need contact with diverse microbial communities dwelling in soil and plants, for example, to form a functional immune system. Urbanization has led to biodiversity loss and reduced encounters with commensal microbes, which elevates the risk of immune-mediated diseases for urbanites. The composition of the human microbiome is affected by the surrounding environment, and the human microbiome affects human health. And for example, it's been found that the composition of the microbial community on skin affects the functions of the immune system. Since people spend a lot of time working indoors, we could promote beneficial microbial exposure by enhancing microbial communities in workspaces. We tested if green walls would enrich skin bacterial communities and induce immune responses in offices. We did a 2-week intervention in 2 cities in Finland with 29 people. The experimental group received green walls in their offices and the control group did not. We collected skin samples for bacterial analysis to observe shifts in bacterial communities and blood samples for cytokine analysis to observe immune responses. Regarding bacteria, we were interested in diversity of the communities and relative abundance of health-associated taxa. The cytokines we measured were either pro or anti-inflammatory. The samples were taken on day 0 before the green walls arrived, day 14, the last day of the intervention, and to follow up 2 weeks after the green walls were removed, day 28. We found that the relative abundance of lactobacillus, which is known as the beneficial genus for the health and integrity of skin, increased in the experimental group during the intervention on day 14. In addition to observed values, we compared the amount of change in contrast to day 0. On the follow-up day, the change in Shannon diversity of phylum Proteobacteria and its class Gamma Proteobacteria differed between the experimental and control group, so that in the experimental group, the diversity had increased. This seems nice since high proteobacterial diversity is associated to a lower risk of certain immune-mediated diseases. In the cytokine results, we found that the level of pro-inflammatory IL-17A was connected to a higher proteobacterial diversity, although this result was seen in 1 city. But since the green walls increased proteobacterial diversity, in the follow-up samples they could lower inflammation. Comparing the change on the follow-up day, the level of anti-inflammatory cytokine TGF-beta1 differed between the experimental and control group, so that in the experimental group the level increased. Due to the beneficial bacterial changes on skin, green walls may enhance skin bacterial communities. And the cytokine results indicate that the green walls in this study may have immunomodulatory potential that should be further researched. Thank you for listening.